Hi, everyone. Yeah, okay, today's topic, you can see it at the top of the screen there. We're just going to spend another day working through radical operations. So the first half of today is going to act like a review of your previous day. This is going to give you a good gauge as to where we are with the material. I think we should be fine to be able to work through the first half of today pretty easily if we've done our practice from previous day. The second half of today, we're going to kind of look at a new concept. And we're going to kind of take a little bit of a different approach as to what the instruction simplify means for us. So we're going to kind of break up today into kind of two parts, but we're really dealing with radical operations throughout the entire thing. So what I'd like you to do is take a look at the 4 problems that you have on the screen. And I'd like you to work your way through and simplify each of those 4, like to the point where we almost view this as a little bit of a practice quiz. You're going to go through and you're going to answer this as if it was a test version of something. Okay, so you get down these 4. We'll meet up in the end and we'll check and see how well we did. Pause the video now. Okay, we're back. So, since this is all review, I'm going to go through pretty quickly today to make sure that we're good. This is just a matter of checking our solution with a few little reminders. Okay, if I'm going to try to be as efficient as I can be, maybe I look at that and I notice that I've got a 3 and a 2 in that 6. So when I multiply those 2 radicals together, I can see that I'm going to take my 4 times my 2. There's my 8. But I'm also going to have the 2 3s that I can take the square root of. And so my entire coefficient then is going to be the 4 times 2, which gives me my 8, times another 3. There's my 24. Now, since I've already dealt with the 2 3s underneath the root, the only thing that's left over is my root 2. We could come in straight with that and you are good. Of course, as mentioned yesterday, we could have gone through and said that we had an 8, root 18, then look to simplify root 18, take the square root of 9, which is 3, multiply that by the 8, and get down to this. Of course we could. So I don't want to shy anyone away from that blue. Just remember, you can just give me the red. Okay, we take a look at B. I'm adding my expressions together. I notice I don't have the same thing underneath the root, so I'm going to try to look and see if I can reduce. Some of us aren't even writing down these factor trees anymore because we can just see the number, or at the very least, we can do that operation in our heads. So if I reduce my first one, I can take the square root of 4, which is 2, multiply that by my 2, I'm left with a 5 underneath. Take my square root of 9, which is 3, multiply that by a 3, and I'm left with my 5 underneath. And now I do notice that I have like radicals, put them together. There we go. So hopefully we match up on the first 2. Everything checks out. Now let's take a look at those next 2 problems. We noticed that we jumped pretty big to get to C. There was our doozy from last time. So again, we're hopefully following BEDMAS, and I'm going to square that big perfect square. So I can square my 2, which is 4, square my root 7, which is 7. Now multiply my 2 inside terms together, and then double it. So if I multiply them together, I'm going to get a negative 10, so I need a negative 20. And when I put those together, I'm going to get root 14s. And now in the end, I have to square my last, so square the 5 is 25, and square the root 2 is 2. I'm probably going to spend a line just going through and putting that stuff on the inside together. I don't think it's a big jump for us to say, that's going to give us a 28 on the 4 times 7, and that's going to give me a 50. So my 28 and 50 is going to collect, and there's my 78. And now I can multiply in. Well, I got to do a little bit of a calculation. So 3 times my 78, well, 3 times 70 is 210, and 3 times 8 is 24. So 234 root 5. And then I have my minus 60. And now, as soon as I'm putting these together, I can already see it will be a reduced radical. because all I'm going to have is my 5, a 7, and a 2, and I know that I have no 2 of the same factor. So when I go through and I multiply my 5 times my 14, there's a 50 and a 70, and we are good. So again, hopefully we matched up in the end. You could have more lines put in, but I would argue to you that I think that those are probably the fewest lines that I would want to see in terms of a solution. If there was anything less than that, then I think I'd be questioning how you got to that value. Okay, and now we take a look at D, and D should have been, I think, the easiest one of them all. That we take a peek, I have one term on top, one term on the bottom. I can divide out my whole numbers, my coefficients, and that gets me down to a 2 root 3, and we are good. So you had a little bit of a jumbled quiz. Those first 4 problems should have acted as a little bit of review from last time, and that should give you a really good gauge as to where you are with the previous material. Now what we're going to do is we're going to jump into like the second part of today, and we're going to take a look at a different way or something new that we have to consider when we simplify. Okay, here we go. Okay, so let's take a look at problem E now. And you'll notice that really all I've done is I've just changed problem D to problem E, and on the bottom, I've put a root 2 instead of a 2. Okay, so how would we end up tackling something like E? Well, our first look, given what we've covered up to this point, we can divide radicals. Our problem might be, though, okay, a root 3 does not divide by a root 2 evenly. Okay, so that's not going to be of help. Well, the next part then becomes, well, but maybe I end up getting a root with like a decimal underneath. Because like 3 divided by 2 is like 1.5. And we're going to talk about why we can't have decimals underneath our roots in a moment. So how do we end up tackling something like E? Like we look at it and we almost maybe go, I think that is fully simplified. There's something in E that I need to address with you. And it's something from a concept standpoint that you actually have background with. Like right now, go ahead and punch in root 2 on your calculator. Now, we're going to get that root 2 is approximately equal to like 1.41421356 dot. Now, the first thing I want to make sure that we're good with is please, again, don't think that that's exact because it took up every space on your calculator screen. We've had our discussion about irrational numbers and the fact that they are decimals that go on forever and never repeat. So that's why I have to mark that as a rounded figure. Like it's approximately that. Okay, so really, let's change this question then and let's make it just a little easier to see. Imagine I gave you this question. And I said, well, what's 6 divided by root 2? Let's look what that actually means. If root 2 is like 1.4142, blah, 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 approximately, then what that question says is take 6 and break it up into 1.414, blah, 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 groups. And I hope that you can see that that doesn't make any sense. That I can't take 6 and break it up into an irrational number of groups. Now, you did revisit this topic, or I shouldn't say revisit it, you did visit this topic way back, like probably grade 9, maybe even earlier, when we started to address it with things like a negative on a bottom. Like what if I said to you, take 6 and divide it by negative 2? So take these 6 things and break them up into negative 2 groups. And we learned pretty quickly that a negative on the denominator doesn't make sense. And so we would then adjust it and rewrite that as, so that we now had a positive integer on our denominator because that makes sense. Now, it doesn't mean that you can't have a fraction that has like a decimal in it. Like I'll give you that like 6 over 1.4. Let's just say it was 1.4. Well, that doesn't make sense. Take 6 things and break them up into 1.4 groups. Like I either have one group or I have 2 groups. But how do I have one group and then a part of a group? And so what we learned was we can't have decimals in our fraction. That doesn't make sense, especially in our denominator. And so we would have then had to spend time saying, okay, 1.4, well, every 0.2 is 1/5. So maybe I look at that and I go, that's 1 2/5. Oh, so that bottom is just a 7/5. And then we would divide fractions, so we'd flip and multiply, and you'd actually change that fraction into 37ths. Because now I can take 30 things and break them up into 7 groups. 7 doesn't go into 30 evenly, so it doesn't mean that I have an even number of whole things in each group. I'm going to have a certain number of whole things, 4 whole things in each group, and then 2/7 of each thing in each other group. That us working with the form of a fraction always had rules to it about what makes sense. So you learned that you couldn't have a decimal in your fraction. You learned that you couldn't have a negative in your denominator. Well, now all we're really going to do is we're just going to address the fact that, well, we can't have a root in our denominator because it doesn't make sense. So our goal then when we take a look at E is how do we get rid of the root on the bottom? And I would bet that within a short period of time, like it might have already come to you, you could come up with a strategy for how to get rid of a root, a square root. Like how do we get rid of that root on that 2? Like we've already seen it happen as we go. Well, maybe I multiply it by itself. That is, take a look at question 1C. When we squared a root, when I square root 2, then I just get 2 because squaring is the opposite of a root. And so they cancel each other out. So maybe we tend to think, hey, why don't I just square it? So our reaction then might be square that fraction. Because watch, like what I get on top is 4 squared is 16, root 3 squared is 3, all over 2 squared, root 2 squared is 2. Hey, look, my square root's gone. We can't do that. Now, what I'm going to do is I'm just going to put up an easier example just so we can see why we can't. Imagine that I gave you 1/2. And you decided to square that fraction. Well, when you square 1/2, we're going to get 1/4. And pretty quickly, I hope you can see, you just changed its value. 1/2 doesn't equal 1/4. So by you choosing the action to square, you actually change the value of it. And we know we can't change the value of the expression. Now, for anybody who's wondering, like, but why did the value change? Let's go back to like grade 6 maybe, or maybe even earlier, grade 5. Keep in mind that when we actually squared that fraction, what we really did was we multiplied the top by 1 and we multiplied the bottom by 2. And you've learned pretty quick that to keep a fraction's value the same, you can multiply the top and the bottom of a fraction. You just always have to multiply it by the same thing. And if we square a fraction, then we're probably multiplying the top and the bottom by a different value. And so therefore we've changed the value of the fraction. So that's why squaring is not going to work. However, there is another way. Just change the wording in your head. Then when we say multiply it by itself, then I'm going to argue to you, then just multiply it by itself. Why don't we just multiply that bottom by root 2? And you know enough that if we multiply that bottom by root 2, well then root 2 times root 2 is 2. Nice. We achieved our goal. We got rid of the root on the bottom. However, if I just multiply the bottom by root 2, then I've changed the value. So I better make sure that I also multiply the top by root 2. So if I change my top the same way I changed my bottom, then my top becomes 4 root 6, and I've maintained the value of my expression. Now, before we finish off that problem in red, let's go back up and take a look at the green, at exactly what we're doing. I'm just going to erase that green because I want to put in something that's extremely important for us. This is all we did. We just multiplied the fraction by 1. And you know that if we multiply by 1, we don't change the value of that fraction. The only thing is if I just multiply by 1, it's not going to cure my problem. So what I'm going to do is I'm going to choose the value of 1 that's most useful for me. And the value of 1 that's most useful is root 2 over root 2. So if I got rid of that 1 now in the middle, you can see that that green fraction is just a value of 1. And so that's why we're able to do what we just did. Now, there's a name to that. And I'd like you to get it down. We're going to formally get it down next lesson. But what that process is called is rationalizing the denominator. I want you to notice that what we've done by multiplying by that green fraction is we made our denominator a rational number. It's no longer an irrational number. So what we did is we rationalized the denominator. Okay. Now we can finish off in red. So if our focus comes back to that red, we notice that we can now divide out a common factor of 2. And that whole thing shrinks down to 2 root 6. And notice that makes sense to us as a value. Okay, there's our approach. And so the couple big takeaways from problem E is that if we ever have a simplified fraction where we can't deal with common factors, we can't do any more operations, and it has a root on the denominator, then we got to stop and we have to recognize that we're not fully simplified. Doesn't make sense yet. So we may have to go through that approach of rationalizing the denominator to fully simplify. Okay, let's get some more practice just with rationalizing. Okay, so what you see on the screen now, you got 3 more problems. We're going to take them in their bits. So I don't really want you to tackle all 3. They're going to cause some different kind of issues to arise. What I want to do is I want to take it slow. So let's take a look at F specifically. And I'd like you to go through and fully simplify that expression. Okay, pause the video now, complete F. Okay, we're back. So we notice that we can't divide out common factors right now. There are none. I have a whole number 3, and then I got a radical. But I notice I've got a root on the bottom. So how do I get rid of my root on root 6? I multiply it by itself. And if I multiply that by itself, then I got to multiply the top. So notice I am multiplying both the top and the bottom by the same value. There's my root 6. When I do that, my top is going to change to 3 root 6. My bottom becomes 6. Now I take another look and see, can I simplify further? Yes, I can, because I have a common factor. And if I divide a 3 out of the top and bottom, then I get root 6 over 2. Again, please don't look at that and go, oh, but wait a sec, I got a 6 and a 2. You do not have a 6. You have a root 6. So we can't divide out that 2. Okay, hopefully we matched up, and we're doing pretty well. Okay, now I'd like you to take a look at G. So I want you to go start to finish and fully simplify G. Okay, pause the video now. No, okay, we're back. So I'm going to tackle G 2 different ways. And what I'm going to do is I'm going to do a purple solution. And this purple solution, I would almost bet that the majority of class right now would tackle it this way. That they would look at the 2 and the root 18, see that they can't divide anything out, but they recognize that we have a root on the bottom. So we're going to multiply the bottom by root 18 because that will eliminate the root, but I know I have to multiply my top by the same thing. That's going to now give me 2 root 18 on top, and on the bottom, root 18 times root 18, 18. My goal has been satisfied. I just rationalized the denominator. However, we might look at this now and say, hey, look, I can divide out a 2. And that gets me root 18 over 9. I just want you to be very careful. Notice, I can reduce that root 18. And so what I'm going to do is I'm going to actually go backwards. I'm going to get rid of everything I just wrote. Because maybe my motivation instead was I'm going to reduce that radical first. I like that as a motivation. Reduce each individual term as much as you can. So if I do that on the top, then I can take the square root of the 9 is 3, put that together with the 2 is 6. I'm left with the 2 underneath. And now I take a peek at that and notice I can divide out my 6 from both top and bottom. And I get root 2 over 3. Okay, that purple would have been what I would have guessed the majority of the class would have had down. I want to show you a different way through. Because I'll be honest with you, I wouldn't tackle it that way. My big or here would be I'm motivated that if I had that original expression, and I'm just going to copy down the original expression again, that this is the approach I would take. I would first look at that and say, well, can I reduce any individual radical? And I take a look on the bottom, and I have a 9 and a 2, and so I could reduce the bottom to a 3 root 2. Well, now I take a look at that and I say, can I divide out anything in common? And I do not have anything in common. Be careful on the 2's. One's a 2, one's a root 2. Very different values. And now I decide to rationalize. One of the things that might surprise some people is when I rationalize, I'm not going to multiply by 3 root 2. I want to be very clear here. Our decision to rationalize is to try to eliminate the radical on the denominator. Yes, if I multiply the bottom by 3 root 2, then I'm going to get 3 times 3, root 2 times root 2. I get 18 on the bottom. Notice, we have the same bottom. We get to the same, because those are the same values. However, I like to keep my numbers small. So I'm not going to multiply by 3 root 2. I'm only going to multiply by what's needed to rationalize the denominator. And that's by just root 2. Notice that if I go through and I multiply that denominator by just root 2, then my denominator becomes 3 times 2, which is 6, and I get to work with smaller numbers. It's still rationalized. So my form of 1 that I'm going to multiply by is actually just root 2 over root 2. That makes my top a 2 root 2 when I multiply, and now I can divide out my common factors, and I get down to my root 2 over 3 right away. Now, you might be asking, okay, but why would you do that? It looks like it maybe took a little more thinking. And I would argue to you, it does take a little more thinking if you want to think of it that way. But notice that my goal was the same the whole time. Just simplify. So make my radicals as small as I should. That should be your goal all the time anyway. Now when I go to multiply, to rationalize, how about we multiply by the smallest thing possible? Notice all my numbers in green are going to end up being smaller than my numbers in purple. There's my benefit. I just get to work with smaller numbers. So that's something to keep in mind as we move forward. Okay, you guys take a look at H. I want you to go through and I want you to rationalize h. Fully simplify it. Okay, pause the video now. Okay, we're back. I think h is actually pretty straightforward. That if we take a look, as long as nobody thought to try to do that, because you recognize that you have two terms on top and root 2 is not a factor in both of those, that we can't divide out that root 2, so we're stuck rationalizing. What would I multiply the bottom by? Got to multiply the top by the same thing. So what adds the little wrinkle to in h? Just make a note that I am multiplying two terms by one term. That means that I need to expand in my root 2. I have to make sure I multiply the whole numerator by root 2. So that's going to get me my 3 times 2 is 6 minus my 5 root 2 all over 2. And we're good. We notice that we don't have any common factors. We are fully simplified. My denominator is an integer. Perfect. Okay, that's what we're going to be dealing with today. And all we're going to do is just get into some uglier circumstances. So let's take a look at the next one. I want you to take a look at I. And all I'd like you to do is try I. So this one might take a little bit of stumbling. Like you might be trying something, maybe it doesn't work, so you try something else. We're going to stumble our way through I. But I want you to use all of your background information and try something on your own. Don't wait for me. Okay? Give it a shot. Pause the video now. Okay, we're back. So, one of the things that I would have expected from a lot of people, this should have been most people's first attempt. And whether you actually wrote it down or not, it probably should have been what you considered first. Like you see the root 2 in the denominator, and to get rid of a root 2, we'd have to multiply by root 2. Here becomes the problem. That when I multiply that bottom, I notice I have to multiply into two terms. So my denominator would then become 3 root 2 plus 2. And yeah, I got rid of the root 2 on the 2, but I'm stuck with it now on the other term. So really all I did was just change where the square root operation, where the radical existed. That's it. It didn't get me to my goal. If we didn't write it, it should have been likely the first thing we considered, and then we recognize, oh shoot, that didn't really help me much. Okay, I'm going to ask you to do something a little weird within our video. I'm going to actually ask you to pause the video in a moment. And what I want you to do is I want you to look through your notes from your previous lesson. And I want you to see if there was anything in that previous lesson that can help you through I. So this might take a couple minutes. Like this might take 4 or 5 minutes for you to kind of look over our last lesson and see if there's anything. Hint, there is something in there that helps you. If you find it, then I want you to try to use what you see and see if you can stumble your way through this with a little bit of problem solving. Okay, what we're going to do is we're going to pause the video. You're going to go on the hunt for your strategy. And then we'll meet back and we'll talk about how we can deal with this one. So pause the video now. Okay, we're back. So you are either back and we are ready to go, or you are back because you are completely stumped and you couldn't find anything in your notes. If you are completely stumped and couldn't find anything in your notes, either you're taking bad notes and you're not listening to your instructions, or we just overlooked something. I'm going to ask you to give it another shot. And what I'm going to ask you to do, go and look for a problem from last time where you put a huge star on your page. Huge star on your page. Okay? Give it another shot. Pause the video. Okay, we're back. So now I should have everybody here. And we either found it on the first go, we found it on the second go, we were good at being able to use it and you have a solution, or you found what I was talking about, but you aren't quite sure in how it's going to help you. So let's take a look at I. The next attempt I would have expected a bunch of people to try would have been this. Because that's what we did before. That we said, well, the way that we can get rid of our radical on the bottom is we just multiply something by itself. Here becomes the problem. Our denominator is going to become 9. And now I'm going to have a 3 root 2 and another 3 root 2. So there's a 6 root 2. And notice you still have your radical on the bottom. So I think we took a better step by saying that we had to multiply by multiple terms, but we just didn't quite have the right expression. I am hoping that what you found when you looked back on your last page was the problem with a huge star I asked you to put on, and hopefully what you saw was that we had an instance where we did radical operations last time, where all of our radicals disappeared. And it's when we multiplied by the conjugate. I want you to take a look at your denominator. Your denominator was 3 plus root 2. When we just tried that last method, we couldn't get rid of our middle term. But if I multiply by its conjugate, the exact same terms, different sign in between, we're going to see that our middle terms cancel out. So my best option is to use the conjugate of the denominator. We'll just deal with the denominator first so we can see it in practice. If you put the blinders on, this is what you're going to do. You're going to go 3 times 3 is 9. Now you're going to expand your outsides, minus 3 root 2. Now your insides, plus 3 root 2. Now your lasts. Then you notice, hey look, my negative, my positive, cancel out, beautiful, my roots are gone. I'm going to argue, though, that I think we should be better than that. That we chose that conjugate for a purpose because we knew the middle terms canceled out. So if we know the middle terms cancel out, then why are we even expanding to get them? 3 times 3, root 2 times root 2. There we go. Just watch out and make sure that we have a minus in between. Notice if I am multiplying by conjugates, then my last terms will be different signs. So that means I need to subtract. On top, I can just expand that in like normal. Okay, so I get my 3 times 14, which is 42, minus 14 root 2. The only thing left to do is let's clean up the top. And now take one more look and see, can we simplify? Well, I have 2 terms on top, 1 term on the bottom. I'm looking at my 42, 14, and 7, and yes, they all have a common factor of 7. So I can divide out a 7 from all of my whole numbers, and that whole thing shrinks down to 6 minus 2 root 2. There we go. Nice. In all seriousness, I don't think that there is anything more that I can throw at you guys in terms of rationalizing. It's a matter now of just getting some practice. You're good at being able to rationalize a fraction with a single term on the bottom, or now with a binomial on the bottom with 2 terms. So let's go ahead and take a look at J. I think you should be good to be able to go through start to finish on J. So let's pause the video now, give it a shot. Okay, we're back. So we take a look. I can't reduce it as is, so I need to rationalize it, and I'm going to multiply by the conjugate of my denominator. That means I have to multiply the top by the same thing, and now all I have to do is just take my time and multiply. So on that top, I'm now going to have a 5 root 6 plus a 30 root 2 when I expand that in. And on the denominator, I chose my conjugate for a reason. Root 3 times root 3, 6 times 6. Okay, I do a little cleaning up. And then we get to a point where we hit a bit of a wall. Not a wall, I should say, but we hit a bit of a snag. We notice We're not finished because we have that negative on the bottom. Well, for what I said on the last one, it shouldn't surprise us that if we are multiplying by conjugates, then the operation that we're going to have in between those is always going to be a negative. I'm going to get my difference of squares. And anytime I'm subtracting, well, then there's a pretty good possibility that I'm going to get a negative. Like I might argue to you, it's like half the time. So the fact that we get a negative down there shouldn't really surprise us. We should be good then to take that negative, move it up, and apply it to the top. So my top then becomes negative 5 root 6 minus 30 root 2. Expand that in, and we get our 33. Now, why did I just move the negative up on top? Well, I was using a little inspection. I noticed that 5, 30, and 33 do not have any common factors. So I didn't have the opportunity to divide out a negative common factor. So I just moved my negative up on top and simplified. I couldn't do anything with regards to the top. Both terms are negative, so I couldn't then rearrange the top to enable me to write a positive term first. That's my final form, and we are good. Nice. Okay, let's jump in. One last one. Okay, question K. I'm going to argue to you that I think K is about as ugly as I could throw at you. I think it becomes a great gauge for us in terms of rationalizing. So I want you to go start to finish. Let's pause K. Give it a shot now. Okay, we're back. So as we're working our way through this one, we notice this would be, I would argue to you, your only horrible thing. Hey, look, all that stuff divides out. If we're making that mistake now, we're missing some serious theory in terms of our simplifying. I've got 2 terms on top, 2 terms on bottom, and there is not a common factor in all 4 of those terms. So I'm going to rationalize. Make sure that we didn't do something like this. And I do want to address that because there can be some misconception when we talked earlier about when we had a 3 root 2 on the denominator and whether we only had to multiply by root 2 or not. I just want you to notice that when we have multiple terms, I have to multiply by the conjugate. Right now, if I were to expand that, on the bottom, I'm going to get 2 times root 2. Then when I deal with my outsides, I think you'll notice I'm going to get negative 2 root 10. And then when I put these together, these should have been conjugates. So I would have got a positive 2 root 10. But now my next one would only be a negative root 10. And you'll notice those middle terms don't cancel out anymore. So as soon as we see that we have multiple terms that we're multiplying, it has to be the conjugate, which means the exact same terms, different signs in between. There's my form that I need to multiply, so I just need to make that my form of 1 that I'm multiplying by. Okay, the rest of this then is just take your time, make sure we multiply correctly, and then we simplify. So on the top, I'm going to get a 6 times a 2. Now I'm going to get and if you want to write this down, you can, but I think we should see that we're going to get root 10 middle terms. I think we should be okay to say there's a 3 root 10 minus a 4 root 10. And rather than go through and simply write out 4 terms, why don't we just collect that to my negative root 10 right in the middle? I understand, especially for this first one, though, where we may look at it and say, okay, this is the first time I've ever been asked to do it. I'm just going to take my time, and I'm going to make sure that I get there. Multiply your lasts. On your denominator, this one can be a little faster. Square your 2, square your root 2, square your root 5. So all we have now is a bunch of cleanup. On top, there's a 12 that I've circled, minus a 10. So we should be okay to say that my top is a 2. And then when I put together my roots, I have a minus root 10. And on the denominator, I've got an 8 minus 5. There's my 3. I take one last peek. Notice that I cannot simplify further. I am good. My denominator is a rational number. Perfect. Okay, I'm hoping that today gave you a little bit of insight as to where we can go with some stuff. And you now have everything you need for radical operations. We should be good to be able to multiply, divide, add and subtract, square any expressions with radicals. And now we can get over that next hurdle of rationalizing a denominator when needed. Okay, same thing as normal. Now all we need is some practice. So let's jump in, let's knock it out and make it automatic. Okay, best of luck.